Okay, so this one's a little bit different because it involves a radical. Now before we find the inverse, let's look at this function and find the domain of f. So the domain of f, it's going to have to be from 4 to infinity, right? Because we need x minus 4 to be greater than or equal to 0. So that's the domain of the original function. Sometimes it's easier to find the domain of the original function, and then if you need the inverse, the range of the inverse, then you can do that. Okay, and vice versa. So like if they ask for the domain and range here, that's a little trick. Okay, so we're going to go ahead now and find the inverse. So we'll say y equals 2 plus the square root of x minus 4. So this would be like step 1. Then we're going to switch x and y. Step 2. And then, let's see. Oh, we have to solve for y. Okay, so x minus 2 equals the square root of y minus 4. Now, how are you going to get rid of that square root? Well, you're going to square both sides. So square this side and square that side. And you can multiply it out. I'm not going to, but it just depends on the form they want. So I'm going to have x minus 2 squared equals y minus 4. And then I'm going to add the 4 over. So x minus 2 squared plus 4 equals y. Or, y equals this, but I'm just going to make it f inverse of x is equal to x minus 2 squared plus 4. That's a form that we often leave quadratic equations in. Okay, but now what's going to be the restriction? Well, we don't know. We have to go back up to our domain here. Well, if my smallest output here, if the smallest thing I can get here, the smallest number I can get is 0, which is true, right? We said it has to be 4 to infinity. So if I put in 4, I get that to be 0. Then my 2 plus 0, that's going to be my smallest output. So the range of the function is going to be from 2 to infinity. And you can graph that. You can use transformations and stuff and graph it. Okay, since I found the range of the function, then I know my domain for the inverse. So the domain for the inverse is 2 to infinity. Okay, so if they ask, sometimes they ask. All right, there we go.